Alright, they say make some goofy face and like make a gesture with your hand pointing at the center of the screen for the thumbnail. So there's your thumbnail. Welcome to the Awkward Performance YouTube channel. This is take like 297. I don't know if I'll ever get used to this. We got a whole itinerary of things to go over, and you get to enjoy it with the nice Bandicam theme that way. I don't know if I'll go away from the free version. I just don't know if I will. I have, like I said, so I have an itinerary of things I'd like to go over. First, I'd like to address the first video that I shoddily took in my shop around midnight. I didn't expect that thing to go to 20,000 something views, and thank you for the 1,300 and something subscribers and all of the activity in the comment section. I had no idea that we had this many engine enthusiasts still around. And I kind of knew, watching all the different channels that do engine research and testing and whatnot, but boy, I didn't think my little shiny object in the thumbnail and the title of like 4 Valve LS Heads and the word billet somewhere in the title would garner so much attention. So thank you all. I'm taken aback by it, and apologize for taking so long to get back to doing a response video, but I figured I owe it to y'all, and I'm going to go through some I'm going to go through some of the things that I'd like to share with you. In CAD here, I have a couple of different documents open. Some are dated, if you zoom in there, like 2023. I've been working on this since 2020, late 2020. So I have some more modern ways or modern files, and some updated rocker arms, for example. This is the roller rockers that will be coming on the heads. I'm moving away, for example, no, that one, from like having an independent adjuster on the rocker arms to set your valves. I have some other solutions for that, and this should really help just make these things run better and eliminate a lot of work on my part for doing a wear study. This is just my most complete CAD model to kind of show you the concept. So on the list of things, I figured I would adjust, or on the list of things that I kind of generated from the comment section as a list, I figured I would go over a lot of the frequently asked questions. And I apologize if I didn't get back to you. I tried my best to respond to each and every one of you if it was applicable. But there's a lot of comments, and I typically work from about 10 a.m. to about 10 p.m. to sometimes midnight on my day job. And that day job is popping off right now. So I'm doing all I can to continue working on this behind the scenes, and I'm finally capable of working on a video to put out and clarify some things and share some cool features with this and put you in the CAD. I know this might be a different style of video, but a lot of times people don't share a lot of detailed CAD drawings. I'm not claiming I'm completely right about everything, but this I know will work, and this is designed to be made on CNC machines out of billet, and I think you may enjoy getting an inside look on how something like this is maybe drawn up, and all the kind of hidden details within it. Because there's certainly some detail in here. So if that will enable, okay, maybe it won't decide to. Anyways, the list I got generated from the comment section is in a range of everything from, well, I'll just go down the list. The price for the cylinder heads, whether I'll be getting a patent on it, I'm not. The intake and exhaust combinations for this thing, I'll go through that. How do the water jackets work? Divorced intake ports. Oh, my favorite one. The rocker arm weight and the push rod system that will operate these. I'll go through some detail. I'm not going to try to rabbit hole completely. I'm already off task or off topic from reading a list to show you how bad I am at it. But I'll show why push rods and rocker arms are absolutely the best way to go about valve train and not those old stinky overhead cams. Can laugh at your own jokes. I'll also go over material choices, what the heads are made out of, what the rockers are going to be made out of. Spoilers, aluminum, but different alloys. I'll go over the manufacturing of them, so the machining and why things are designed a certain way to benefit CNC machining as opposed to a other method like casting, or some questions on additive manufacturing or 3D printing cylinder heads. I'll try to go over some of those things. Some cost justification, what the goal of these cylinder heads are for hopefully the end customers, and why this should be actually an extremely good value depending on what you're doing. I think it would be regardless. There seems to be as much enthusiasm as a cool factor as there is, hey, you might be able to make, north of 2,500 horsepower with these. The goal is to beat those dastardly Coyote engines, and if those people start rolling out the 5.6 liter Nissans, these American engines, well, not that the EcoBoost V8 isn't an American engine, but the Chevrolet Cam block style engines, this is a way to fight back and actually be pretty cost effective for higher end racing. And then the last thing, which I'm kind of uncomfortable and I feel it feels awkward to ask about doing a crowd-funded Patreon and pre-order type thing. I'll go over some of my thoughts on that, but more importantly, I would like to ask the audience if a Patreon style deal could be viable, and how I would implement that to benefit the expediency of these things getting running on a dyno and getting ready for sale. So that's kind of a weird topic for me to ask. I typically usually do everything on my own, but if people are willing to, I think I have a pretty good plan on how to do it, and I'd just like to hear your thoughts on all that. So I guess I'll start with the patent deal. So there's nothing really new here under the sun. Patents, I believe there's method patents. You got your provisional patent for new ideas or new inventions, and then you have just your normal big boy patent. I don't know much more about it than that, and I know the provisional can give you up to 2 years with the extension, and at the end of that 2 years, if you do not file and go through the 30,000 to Lord knows how expensive process to do it, you have to actually forego that patent. And so there's some games that companies will play with the patent pending thing, and it does afford you some protections, and it can leverage you for some licensing, and none of that's really applicable to what I'm doing here. If I have outsources, I will be outsourced machining services, they'll fall under an NDA. If I partner or license with people, I don't really need that patent to drive the licensing process. The methods patent might be the closest thing to try, because I'm using a push rod and forked rocker to run 2 valves off of 1 push rod, and that's new for an LS engine, and here's how I kind of configured it, and this is what makes it special. But there's nothing here really to report home with. Like, all of this has been done before. There's been several different cylinder head manufacturers or startup businesses in the past that have done something extremely similar to this. I've chosen to make compromises in certain ways to aid performance and manufacturability due to my particular means of manufacturing these, and not give the customer any of the compromise. The method of assembly, the method of packaging, it just doesn't apply or greatly here. Like, there's no, again, like I said, there's nothing new under the sun. For example, Harley Davidson right now with their Milwaukee 8 engine, they use a 1 push rod to a shaft rocker that operates 2 valves. And yes, the shafts run transverse compared to the crankshaft centerline or other terminology you would list in a methods patent to set things apart. But again, there's been, Uncle Tony's Garage has been going through that. I think Buick or Pontiac or Oldsmobile, or I think all 3 of them, were all playing with different concepts like this back in the day. And they've timed out. Like, there's nothing new there to patent. The 4 valve per cylinder, like I bet you more of you all daily drive a 4 valve per cylinder engine car than a 2 valve per cylinder car. It's just kind of common state now for economy engines. They're 4 valves are superior in every way to a 2 valve. You can get 2 valves to be pretty damn good to a 4 valve. The LSs and the Hemis nowadays prove that. But we know what's happening at the drag strip if you follow that stuff. And you can watch an engine that's several liters less than big blocks or, larger LSs, and they're going a lot faster. And it's not because the overhead cams make any power. It's because they have 4 valves per cylinder, and all of the advantages, especially when turbocharging comes into play, it's impossible to beat them. But the Coyote, or I like to refer to the Coyote as the Ford EcoBoost V8, they have some limitations to that design. And one is cubic inch, and the other is, I watched this one guy on YouTube one time do like an 8-minute burnout, and the engine was at like 7,000 to 8,000 RPM, and it melted all the chain guides. It's an economy engine. Obviously, it's not designed to do that, but I felt that was fairly inappropriate. You could not put that into a racing vehicle that, say, runs the 24-hour Le Mans or 24 hours of Daytona and expect it to survive. Different drive mechanisms other than fuel economy, general automobile stuff or design would be involved in a racing engine. So I don't know what that drives back around for patents, because every orientation of everything has been done so far. The investment is immense. I don't have that kind of money. And frankly, I don't want to put the time into it. I've tried doing provisional patents on things in the past, and it is a time sink. And then you realize that it doesn't buy you what you want. If you're going to get knocked off by another company or something, okay, maybe it gives you some protection. In this case, if someone puts this much work into making billet 4 valve per cylinder heads, I would just be flattered. And probably try to work with them and try to get my designs made through that way, because they now have the means where I am building the means to do so. So I hope that addresses the patent thing. If I see comments on it, on I should really get a patent, I'm probably going to just pass on by. I've addressed it here. There's just no reason to pursue that. So, next thing on the list, cost. I hope to be in the low $7,000 range for assembled heads. That's valve covers, rocker arms. I will have a base package of valve spring, valves, lower end valve seats, guides. Well, the guides will all be high end. But a reasonably boostable, up to 20-25 pounds cylinder head will be available for a low $7,000. I know people get pretty crazy about billet anything, but let me tell you, when you do it for 60 to 80 hours a week, you start finding that you can't hardly buy, a decent hardwood or a plastic or anything cheaper than billet aluminum, especially 6061. If you get, 70 75 or 7050 or 7095, God forbid that stuff, it is an amazing material. They get more expensive, but the main core of this head is going to be 6061 aluminum, and there's some reasons for that, and I'll address later in the video. But one of the advantages that the 6061 grade aluminum has is it is some of the cheapest aluminum that you can buy due to its universal the universal use of it and the volume that is sold in the market. It's just the cheapest out there because they just make the most of it, and it's the most efficient way that the market yields an excellent material that you can easily buy. The intake manifold, I'm going to have to charge extra for. No stock LS manifold does not fit my diesel head-esque Power Stroke Duramax looking cylinder head. I'll go over why the intake ports are divorced later, but that's the main reason why it would be such a huge compromise that I would not have a lot of advantage left if I got it to fit, say, an LS3 manifold or LS7 manifold. And then the cathedral port cross-sectional area is so low that would actually begin to limit what the valve area could do and the curtain area. So the intakes I'm going to have available will be a composition of 3D print that are bonded to aluminum billet base plates, and probably the runners that will be printed will be to either another printed manifold or maybe a fabricated sheet metal one, possibly a billet piece. Again, I'm looking at price and what I can do at scale to provide you a great value and to have these things not be compromised by overwhelming frugality. They'll be monolithic when you get them, or one piece. The 3D prints will be kind of cast or like a captured glue line in. And I plan to do a low rise plenum manifold, a higher rise longer runner manifold as well. That way you can maybe fit better for boost or mid-range torque or hood clearance. All those things can be factored in. And then it wouldn't be like me if I didn't have an individual throttle body. I'm a big sprint car fan. I've made billet intakes before. I hope to share some of those and kind of my little change. I don't know if it'll work or not, but I like innovative designs and individual runners. There's always the argument of tunnel ram and carburation, or some form of EFI on a tunnel ram, or do independent runners and injection make more power? And that question will go on for a very long time. But I think the snappiness and the tunability and the just the wow factor of having individual throttle bodies, all of those are pros. One of the things that this can benefit from is, as one cylinder here has two divorced intake runners, these will come up and merge, and I'm still working out the cross-sectional area for the compression of the airflow and keeping velocity up. But these will merge, and where they merge and that divider starts, that divider will actually be the butterfly. So we'll have 8 individual transverse shafts and butterflies, very similar to the Indy Chevrolet Ilmore engine that came out. You can kind of find some cutaway pictures of that online, and that's always kind of inspired me for cool factor. If you got to split the airflow somewhere, you might as well keep it split. And that will go to a tuned ram tube and feed these heads. So I hope that answers a bit of the intake manifold questions. I would be honored if other companies produce their own manifolds for them as well. Doing the cylinder heads is overwhelming enough. So if there's an aftermarket response to supplying parts for these things, you know, one, if you would like to, hit me up in the comment section, and or on FY_LSX Instagram. That way I can get a personal connection with you and maybe send you some CAD files and see what people would be willing to do for an intake manifold. I don't want to leave any limitations there. I think intakes are art. So next thing on the list, water jackets. So these are made to be continuous output, high output cylinder heads. Let's see here. Here we go. Here's a decent cross section. So I have water fore and aft of the combustion chambers, and not so important on the intake side, but very important on the exhaust side. I have water through here, and if you wonder why they look like smiles, it's partially an inside joke, but I actually have some reason for that, and that is to keep the force from the head bolt running down and spreading the load evenly where the LS has their terrible spans for head bolts. It is trying to apply pressure more equally through that area. So as heat comes up or radical cylinder pressure detonation happens, you can better keep a head gasket in these things. And they also have, they're already drilled 9/16 head bolt holes so that you can easily run, sorry, my other computer wants to keep going to sleep. You can easily run 1/2-inch head studs, and I recommend doing so. Don't have to buy my kind of custom length ones, along with push rods to install these and oil drain backs, but that's really all the more unique things you have to do to adapt these to any kind of race car out there, or if you're using a stock car to go drag racing with, they should fit most any engine bay. They're only like 1 inch or 2 wider, and if you run tight turn headers, which I don't like because they kill power, but if you're running a turbo system, where the valve covers sit under that undercut, you can get a header of appropriate size to come out and turn and be under that width. And I'll have some more of those numbers for you as we move down the line of videos. So started that tangent, which I'm terrible about staying on topic. Can't even hardly go through a list without getting off track. But the water jacketing on these is pretty immense. So these are cross-drilled in a number of different ways to utilize the stock head gasket and the stock water flow. That was designed by GM. Some things, if they're not broken, don't fix them. And that's always kind of a, well, why are you making a 4-valve head? And I'll immediately contradict myself. And I hope that's to your all's entertainment as opposed to me questioning why the hell I do this stuff. So the other part of the water jacketing here, in between each cylinder, I have a large volume that the water can store up here, and as things get hot past the very thick, average 1-inch thick deck, they can kind of get in here, and these tubes here, let's see, close that, these tubes here, or holes, transfer the water at a higher volume as the water percolates up and pushes from the back of the engine up to these transfer tubes. Everyone's probably pretty familiar with the LS steam ports on it, and they're probably also familiar with if you go to refill your coolant after doing some service work or replacing our very reliable lifters in our LS engines. Burping these things is a pain in the butt, and I wanted to make that a heck of a lot easier. Mainly at the drag strip, if you blow a head gasket and you're feeling it to pull the heads off and replace head gaskets and maybe try to save this thing 3 coats of copper coat later, when you go to put water back in this, maybe even between rounds, you can jam water in the radiator, and through some porting here, there's a hole here that transfers the water up, and long story short, up into this main channel. And this will, I don't think this is exposed right now, but I plan to have this as a serviceable plug that you can pull and shove water in, and when you get water streaming out each of the banks of the cylinder heads out of these holes, your heads and block are full of water. So you can fill this thing up. You don't have to spend hours burping it, or even just an hour or minutes burping the thing. It's a lot better for roadside emergencies or whatever, because I do see people utilizing these for drag and drive events. So whenever the blue wheel stops spinning and the software stops herring out, this is actually why it took me 500 hours, mind you. It's I probably only have like 75 hours of actually drawing time, because you get a big overwhelming CAD file size, and even though the computer is absolutely screaming the fans at 5,000 RPM for white noise video ASMR reasons, that's why this has taken so darn long. So that, I hope, addresses some of the water jacket stuff. It uses a stock head gasket. All the water does return back out through the block return right here. There's not a left and a right head. Either head, make the same cylinder head, it goes on left or right side of the motor, no problem. And yeah, that should be it. I guess the exhaust side, these water plates here block off the water jacketing. They'll come pre-installed. They're going to have red or green Loctite on the bolts after I pressure check and leak test them. They're all O-ringed for the best chance at them sealing. And so, I mean, if you want to take them off and see my ugly roughing in the water jackets, you can, but I recommend not touching these things. If they're sealed up, let them stay sealed up. Anything else with the water? I think that's about it. Let's go to the divorced intake port. So I've always been taught through all of the grumpy old men that have taught me a lot of things, and my father, who's been building engines for 40 years, ports are typically the most efficient with one port per valve. And this Siamese intake port, where you have a manifold feed the head, and then that port almost immediately divides off into 2 radically smaller ports to the valve pocket on most 4-valve per cylinder designs. They tend to, well, obviously work very well, but I believe there's limitations and there's velocity profiles that, to me, are not as ideal. They tend to have a peakier power band. If you open up the volumes, you're dropping velocity, and I think there's a pretty right way to do that style. But if you look at most of those engines, they're smaller engines, right? So the length of the vane or the divider in the port, if you scale that up to a larger cubic inch engine, that vane logically would scale with that in some size. And that was part of my philosophy here, as well as one port tends to be more efficient to one valve. You have a lot more control over the flow. You don't get flow coming in this port and bypassing and pulling up into the other valve bowl and causing all kinds of weird turbulence and swirl. That's not ideal for performance. If you want real problems, go try to port a 3-valve or a 5-valve per cylinder engine. You'll notice that the dividers are very distinct in those to keep air trying to come back out of one of the ports while the other two ports tend to fill the cylinder. So this is a better way, along with the combustion chamber shape, and I have a minimum relief to fit the 3.78 bore for the small bore engines. The bigger engines, we're going to go to a bigger chamber, but I have to keep that kind of tight. So there is some unideal shrouding with these, but I think the area of them to flow and the quench area here, even though the valves are receded to allow you to run stock flat top pistons if you so chose, these things move so much air, I don't think you'll really be worried about it, to be honest. A way to put it is that these are like two 706 casting intake ports that have been reduced by 2/3. So you have a 66% size 706 head intake port, but you got two of them. So going to be a lot of airflow. Intake valve size is 1.6, exhaust valve size is 1.3. So that's the main reason for the divorced intake ports. Will they merge? Absolutely. So these will merge up, so that way you don't have, a crazy complicated intake manifold. These will hopefully merge up into one port. I'm still doing the math and some of the direction change, and the math is not hard, it's just cross-sectional area calculations, to keep that on a consistent compression and not lose very straight line of sight flow. So the divider, and I think I covered that with the intake manifolds, the divider will come up as far as it can so that each cylinder has a distinct bell mouth to differentiate the flow and pressure from the port from the plenum and or the butterfly for the ITBs. That's always important for your engine tuning and your sonic tuning. So that way it still works more like a traditional intake manifold, and the tuning tricks that you can apply from all kinds of different traditional V8 engines hopefully will apply to these. So that's why this is just an expanded view of a longer divider or longer vane 4-valve per cylinder head. Not exactly, but I'm trying to keep all of those properties in there. So that's why they're divorced. And it gives me room to get the intake pushrod through, which if you want to port these, feel free to message me. I'll tell you where the pushrod clearance and the head bolt clearance is. It's about 62 thousandths. So some areas you can go ham on porting them if you think you know better, or if you do get gains. One, I'm open to hear back what you learn. And then two, don't port where it's thin. Welding sucks, at least on cylinder heads. So I hope that addresses all the answers for the intake ports. Oh boy. All right, why rocker arms and push rods are better than overhead cams. I think crappy overhead cam designs are genuinely worse than traditional lifter, pushrod, rocker arm engines. You can go look at top fuel and what engine speeds that 426 based engines turn. They don't have a problem with the RPM. The Hemi architecture is not great. Hot rod aftermarket world fixes and addresses those issues. Are your spring pressures up? Hell yeah, they are. They're way up there. But it's a racing engine. It doesn't have to live that long, and you do preventative maintenance and service that engine. That's in an extreme case, and I'll probably reference top fuel stuff quite a bit. The valve train on this is greatly inspired by a 426 aftermarket rocker arm setup. The other thing with overhead cams, besides do you run a chain up there? Do you run gears up there? That's like putting a dyno on your engine. If you run a timing belt and deal with that inconsistency and movement, chains over any span tend to begin to really drastically change your timing. And on a highly tuned engine, that can hold you back because you have to detune down to your weakest cylinder, or at least the weakest bank of the engine. There's nothing faster for engine acceleration than a in-cam block V8 because your rotational mass is very low. When you assemble the engine, your human effort of torquing those valve springs down capacitize the engine with that energy. So you can just think that a part of you is inside of your engine with a V8 pushrod style engine. So if that makes you feel better or special, then fantastic. But at about idle speed on the engine, with the V8, with the one cam, with a solid camshaft, when you're lifting these god-awful heavy rockers and this too much spring rate to try to control this inferior design, you have the other side pushing down with the same amount of spring pressure on the cam lobe. So you have frictional losses there, but actually the springs, as much as they're compressing, they're almost getting help besides the force from the crankshaft driving through the timing chain. So if you wonder why NASCAR can turn 8, 9, 10,000 RPM, that's why. Also light valves, also light rocker arms, also heavy spring pressure, also a damn good roller lifter. Camshaft technology for V8 in-cam block engines it never seems to really stop. Materials are constantly getting better, and I think there's a great myriad of brands out there that have a great handle on heavy, severe duty, like valve train components. So these are designed to have up to 400 pounds per spring. So that's like running one 800-pound spring on an engine that only lifts the valve 650 thousandths. You can lift them further, but the head don't flow no more after that. It's kind of asymptotic. So the advantages is the low lift flows in the area under the curve of the floor valve. So I do recommend not only tune your valve spring and your valve weight to the right application, but also work with a camshaft manufacturer, and I'm working with one right now, NK Performance, to develop camshafts for this to best utilize the cylinder head and for your application. I think a turbo cam, a hot street cam, a mild street cam, I shouldn't be saying street, more like off-road or marine, somewhere in between there, a naturally aspirated cam. 5 or 6 different options I think will be developed over some time so that you can get the most out of these heads. The rockers are made out of 70-75 aluminum. That's what T&D and Jessel tend to make their aluminum rockers out of. If you look at Manton, a lot of the Manton rocker arms are made out of steel, and they're very strong, like high endurance style rocker arm. They may not be the lightest thing out there, but again, we have a pretty good handle on what rocker arms do. So while I'm talking about rocker arms, let me bring up the new rocker arm design. So I'm going to a complete roller rocker. The rockers run on a shaft. There will be bearings that are pressed into here. Thrust washers, very standard shaft rocker stuff. They're designed to have a 1/2-inch roller swedged in here with an axle. For the life of me, I can't figure out how to get oil ported through here without losing my mind. The valve cover, the valve cover will have drain back deals, much like a differential or a rear end in a car, that off the splash and the squirt from the push rod coming up here, I will have little, lack of better words, like stalactites hanging down to drip oil over each critical part to keep the rollers and the tops of the valves lubricated with oil. So that's kind of the new rocker arm design, and I have ran FEA analysis on this. I had a buddy that did that, I have just a couple of hot spots. I'll show you where. These radiuses here, we're starting to show exceeding the strength of the materials. So I will be broadening these out because the leverage coming up through here didn't seem to be an issue. It was just these hot spotting. So those hot spots can produce cracks from fatiguing and yielding the metal. So I'm working on a design to lay those back a little bit. And what I did see is there's a big section through here, still a large section through here, that there's some reasons to have this mass here to help transfer the pushrod load from this area over to this valve. The beauty of FEA shows you what's most stressed and what's least stressed. So where you have the least amount of stress, you can begin to remove material. And these are still going to go on a further diet. But just for size comparison, that hole is 1 1/8". So, and they're mostly hollow. These fingers have to be clearance for the spark plug access tube. So there's more weight coming out of these, and it's been a while since I did a gram study on these, but these are actually shockingly light. And the intake rocker, luckily, is the easiest thing on the whole project. So it's a basic extrusion with some fillets. So this I have full faith that I'll have no issues with. This exhaust rocker arm, I'm sure I'm going to get blown up for. But this has got a lot of the beef kind of inspiration from Manton style push rod, or Manton style rocker arms, as well as kind of the I-beam stuff and the other kind of unique and newer contemporary designed rocker arms coming out of Jessel and T&D. So I'm kind of stealing everyone's stuff. Better get a patent on it. But hopefully these hold up. Everything with the force that we put through them on the FEA, these would work right now. The little hot spots in these corners, that was generated because of the way he had the force going through this hole. Really, it's going to be the threads here pushing up through this section. That's where the force is going to be generated. It's not like there's going to be a large torque put out here pushing up to then really focus the energy there. But because it's there, I'm going to do something about it. Let me know if you got any other questions in the comments on the rocker arms. There's some tight packaging. I guess I'll address that because of my shallow valve angles, the exhaust rocker shaft itself is actually clearance to clear the valve springs and the rocker arms from the intake. So there's some tight packaging to deal with. Sorry for setting your valves on the intake. I'll figure something out, hopefully a special tool that'll make it easy. But lash caps and other devices should allow you to balance it, and they're based on like a manly, like your basic lash cap deal. So you can order them from Summit. I'll have them ground in like 5 to 10 thousandths thinner, so that if you somehow get a valve, sinking, and you want to adjust for that, I'll be able to accommodate you. So, and then just your basic jam nut, cupped push rod adjuster will go there. So, all right, I'll move on to the next question. Okay, next thing, material choices. Why am I not casting them? I feel that question gets asked because if there's a cast cylinder head, it's going to be cheaper for you to buy. My proposed price is already cheaper than most of everyone else's 4-valve solutions or 2-valve or Hemi 2-valve cast heads out there right now. Why is that? My friend who was recently on RS Garage, Tom Roberts, friend and mentor of mine, and he shared with me the effort, the cost the trials and tribulations of going through this casting pattern process, and it is an immense investment. It's not impossible, and it's probably best done through him. So if you want to cast a head, go talk to Tom, please. But for things that are going to blow up on the racetrack and get serviced and welded up and go back in a CNC machine, billet tends to be the better choice. If you run a lot of high boost or nitrous or nitromethane with these, I think one of these on nitromethane and naturally aspirated would be absolutely wild. The billet material holds up the best. It deals with the thermal expansion and the radical changes of heat the best. The material density, if you do run a oxidizer, there's a lot more aluminum density for the oxidizer to eat before the head falls apart and parts get completely obliterated. So that's one reason. I won't be casting them. What the heck? Whatever. I won't be casting them because of that. And then two, billet's cheap. It's the cheapest stuff you can buy. That's the strongest stuff that you can buy. So I guess that's a chart of strength of materials and volume of material versus cost. So 6061 is what most, if not all, of your top fuel heads are made out of. Why? Well, they blow them up a lot. Nitromethane problems. But they get welded up, they go back in the CNC machine, and if that process is done correctly, you can't even tell after they've been welded and peened and remachined that the material is any different from the weld from the base material. So my task and my challenge with these heads is to employ my best strategies as a machinist to get the time out. And if you have a cast cylinder head, there's still an immense amount of machining that gets done to them. You got to put in your seat locations, your guide locations, your exhaust face, your intake face, your rocker arm drilled holes, your manifold intake and exhaust holes. Maybe there's other features that you have to clean up from the casting process itself. You have to machine the valve cover rail, you have to machine the deck. Like, the list of features starts to look like you're talking about a billet head machining and casting. And so if you just add a little bit more for roughing, which is the fastest thing that CNC machines can do to aluminum, the billet head begins to look very viable. And I've made some billet heads before. They were air-cooled. A buddy of mine wanted to do some Corvair heads. He recently debuted them at the Corvair Corsa in San Luis Obispo. You can follow him on Instagram at Billet Corvair Heads. They're pretty cool. I did those with the little trending table in my shop. When we went down that line, there was a lot of Top Fuel influences, and we looked at Harley Davidsons and engines that don't even have a fan on them and seem to produce power continuously and don't turn into puddles of metal on the ground. And we applied our best efforts to that design to make it manufacturable and also a great performer. So they're also made to run continuously and use the mass like the Harley heads or some of the later Porsche heads where they absorb, or they have material enough to absorb a great amount of influx of heat and then dissipate that through the heat fins, as opposed to running it really thin and trying to continuously cool it to keep your temperatures down. Well, the cylinder heat from making power will always outrun the ability to air cool or even sometimes water cool. You can't make 2,000 or 3,000 horsepower and then cool it with a standard water pump and an automotive radiator, right? That's why they shut these engines down at the end of the run, to let the engine basically air cool, even if you're a water cooled engine, to let that heat be dissipated, and a lot goes out the oil as well. So making those heads, it taught me a lot of what to do and what not to do. And my buddy Tom told me, why the hell would you cast them? Just make them out of billet. He may have made fun of me or something along those lines too about it, but that's why I like that guy. let's see, what the heck was I on? Manufacturing and materials. Okay. So, the 6061, long story short, is the best material to make these out of. The intake plate will be the same. The head core, or the main cylinder head, will be all that. Rocker arms will be 70-75 because it is a higher strength. 6061 might work there, but it is softer and it does move more. You want a more hard, rigid, non-crack propagating aluminum for rocker arms. And valve seat material, let's see, we'll go back to, is it this one? Valve seats are kind of interesting. I hope to have, for the high-end stuff, a source for beryllium copper. I give great caution with any high-end material or exotic material like that because beryllium copper is very toxic. Standard, these will come with probably a cast iron guide. Sorry, not guide, a seat. And the exhaust seats, kind of unique on this. Let's see here. Let's get over here. That will be pressed in, and it kind of has a Mickey Mouse type shape. And the spark plug will help hold the exhaust seat into the cylinder head. So it'll be tapped through, so you can't drop an exhaust valve seat. I was trying to incorporate the intake seats in on that as well, but that started getting at a weird angle and a pretty complicated part. Typically, intake seats, especially these being 3/8 of an inch deep, put in with a lot of press into a billet head, we should have no valve seat problems. With the turbocharging and the high output and the extreme heat that these can see, I did want to prevent the exhausts from getting shock cooled at the end of a run where you have a lot of fuel and cold air now coming through the engine, while these are, glowing red hot, them shrinking and then them falling down into your engine and having you not enjoy the rest of your day. So rapid unscheduled disassembly is, hopefully I've fought against that little issue. Valves, they'll be stainless out of the box for the 7,000 range price. I will allow you to get as crazy and exotic with this, with the keepers, the retainers, all that. They're 8mm stems right now. It's all based around small block Chevrolet technology. The valve springs are 1.25" maximum diameter. You can run smaller if you want. But that gives you, I think, a small choice of like 23,000 different variants of valve springs to tune to your application. But if you're turbocharging, Inconel exhaust valves are a really good idea. Hollow stems are pretty cool, and titanium intakes will only be to the benefit. I think that does it for materials. Cost justification. If you have a car, and I'll just use this as easy numbers, if you have a car that runs 9.5 seconds in the quarter mile, and you're doing it with a turbo LS, and every 20 or 30 passes, you're doing quite a bit of maintenance or putting head gaskets in it, how many rebuilds does it take to exceed $7,000 to $10,000? Not that many, especially if you have good rocker arms or higher end valves. There's some guys out there that can run on the junkyard stuff for a long time and get it done. They're probably running really, really rich AFRs. But these are supposed to provide a good value. They should run as long as you take care of them and you do your engine maintenance like you would any other racing engine, as long as you're set up correctly, especially if you have one of the cams that's made for this thing, especially if we've consulted with you and determined what valve spring pressures, how long you should run your valves. If you do go to a higher end valve, titanium valves have a time limit on them. Valve springs sometimes have a time limit on them. If you are exchanging those components out and taking care of your stuff, these cylinder heads should last you the rest of your life. If you do blow them up, we can weld them up and fix them. And I plan to have like an exchange program on that, so that if racers are really into doing like the grudge match racing where they're frying these engines and they almost more or less buy a set of, you know, forged pistons and rods. They're running on a stock block and a stock crank, and they have, you know, $12,000 cylinder heads and rocker arms on it and a $6,000 intake. And unlike Top Fuel, where the heads usually get changed out, they're changing out their blocks and bottom ends. These will do you well. And hopefully you'll be able to make a lot more power or the same power, but keep your cylinder pressures down and get a lot broader power band out of it to keep your car at that same speed if that's what you're choosing to do, and have the engine last a lot longer. Or you can step your game up quite a bit and keep your same maintenance interval and save money over time with that. So I hope that explains a little bit of the cost justification. And the other reason why they're $7K, I just can't simply make them for any less. Maybe I can. That'll kind of lead into the thing that's very awkward for me to talk about. Last on the list, the pre-order. I skipped manufacturing. We'll save that for last. The pre-order and possibly doing a Patreon. Let me know what you guys think. One of the advantages that a modern CNC machine has, and a large capacity CNC machine, a lot of machines have, you know, more than 3 axes now. The advantage to going to a large 5-axis is I can get this head core done. I put all the problems of doing this into one component, and if I can make that one component, I've solved all the issues and barriers to doing something like this. And this deal, if this computer will simulate, okay, it's doing it. Just gotta wait. See the blue spinning wheel again. The ability to do this head in under a 24-hour period, I cannot do with my older CNC machines. I can with and I'm familiar with the Haas UMC 1000, UMC 1250, and go ahead and look up a Haas UMC 1250 or 1000, and you'll see that the price tag is astonishing. It's very expensive. And it's one of these catch-22 things. If I don't go and get a machine, I can't really get the volume up and going. But I can't also afford the machine to get up and going. And if I did get them up and going, then if I sold a couple of pairs of heads a month, it would be no issue. Like, not even a problem to pay the monthly payment on that machine. So this is a little bit of a demonstration as to what this machine should be able to do. I don't have this nearly programmed to the end. I have this about 50% programmed for the first operation. That's about 40 hours of programming. Mind you, that's not me programming straight for 40 hours. That is me waiting for the software while it does this stuff to do it. Now, it is dealing with a very large data file, and it's considering the 3D model, the tool holder, the CNC machine spindle, and everything in here. You'll see a little thing down at the bottom here, verification. It's checking if the machine is crashing or if you're improperly rubbing on the shank of the end mill. They have some tools to aid you on this, but if you can process the information faster, long story short, I would probably have the operation 1 done already and be on to the operation 2. So the advantage of these machines, if this thing will stop stalling out, which is beyond, do I have to slow it down to go faster? I hate when I have to do that. This table is obviously a trunnion table, and this can articulate around, and then the UMCs in particular have a high Z gap, or you can fit a very tall part in there. And as you roll these cylinder heads around, the angles really start fighting you. So you need a lot of Z-gap to clear. All right, sorry for the jump cut. Had some issues with having 4 large files open in the computer simulation of the the cut part rendering on a Haas UMC 1000. Something about the data being a lot, and it really suffering processor wise. I think I left off at something about if I were to request or set up, how much support you all would think I would be able to get. Because if I could get a machine like this, I could quickly start producing these cylinder heads. Not only would it make the cylinder head cores, the intake plates, the intake manifolds, the rocker arms, having a 5-axis, a live 5-axis or true 5-axis machine to cut these components cuts down on not only the wear and tear on the programmer, but the runtime. And if I can very accurately and reliably produce these, I would make room in my shop and put one of these in and take you along that journey as well. So let me know what you think. Should I do a Patreon or something along those lines? I have a means to keep moving forward without it, but the thought is sure enticing, and I'm a person that programs these machines on a daily basis, making very complicated parts. It wouldn't be all that much effort to utilize a machine like this for a part that's actually been designed by a CNC programmer to execute. So let me know what you think there. I've given it quite a bit of consideration. There's some used machines on the market that I keep getting sent ads for, and they don't know that it hurts me inside. But I actually do appreciate finding good deals and shopping around. So if that's a thing, let me know. I think that clears up the rest of the questions or the frequently asked questions from the first video. This here should show, that there's an immense amount of machining that happens with these at initially roughing them down. I'm sorry if it looks like a child's cartoon right now. I had to turn the accuracy down quite a bit to get this thing to process, because the computer's still smoking hot. The processor fan's spinning at like 5,000 RPM, and this thing's not having a good time recording a video and doing this simulation work at the same time. I'll make some comments on what's neat and then the challenges of doing the stuff live 5-axis. Under here, this gives you a collision check, a little bit of either silly things going on in the tool path, like these rapid moves into stock. This is not the end of the world, but when you have the spindle of the machine here crash into the table of the machine there, that is typically like a week to 2 week to repair, $5,000 to $10,000 deal. So it's definitely dicey work, and you have to be very thorough on your programming. And that's the price with fancier machines, is you get fancier bills with it if you screw up. So luckily I haven't, knock on wood, haven't wrecked a 5-axis machine yet, and I haven't even broken a tool in a 5-axis machine yet. I've worn them out, but I've had no big whoopsies, and I plan not to. It's kind of a nice thing to have on. Nice thing to know that my approach and my theories on machining and the approaches that you take, which are a little bit more conservative, and a mix of old school machining and kind of the new school machining and utilizing some of these new tools, it seems to work pretty well to have a hands-off approach for the machines running. The hard work's done at the computer. So that'll pretty much tally up the end of this. Oh, I was going to go and show what's going on with this. I have to build a spacer, for example, if I'm going to utilize this method. But let me go digging for the other way about this. So I'll show you the trunnion table that I'm looking to build, well, halfway built. If I do proceed to develop these, and I plan to at least do one cylinder head this way in my shop. That forces me to have the CAD and CAM lined out to where not only can I produce them on my little shop's, you know, meager abilities, and not cost me $1 million to do it. If there's repairs that need to be done on the cylinder head, I will most likely do them on the older machines. When you're starting from a blank block, it's much easier to utilize the new machines to go and execute what you need to do for production. But tuning and doing custom work, sometimes going to a simpler machine where you're going to be rewriting the programs and don't want to work so darn hard at that program, I can do easily on my older machines. So let's see here, models, pop down here, and then we'll turn the lane vices off. So this is how, I guess it's not showing the, sorry, bear with me for a moment here. Like the fixture. Well, you might have to use your imagination. Let's see here. They're all shown. Anyways, this is your essentially your fourth axis through there, and then your fifth axis is on a rotator. So with 3 dimensions of movement, I can do quite a bit of the porting. So if I align like this and come down with the ball end mill, I can actually do about a quarter of the port. And through my other cylinder head making, the corners of the port are what you target. You get your corner radius right, and you get that feeding happy, and you can pretty quickly move down these corners, and then you can go to the easy spot and hit these flatter surfaces here. So you'll hit it from the port entry direction, as well as I made sure to design these ports to where I can actually have access to the short turn radius, and to get good access to the bowl, and to get a fantastic blend from this side to that side. The advantage of this system, which I'm sorry for not having populated, I don't know exactly where that went, I'll be able to move these with the power on, or a power off brake. So I'll be able to hit a button and the brake will come off, and I'll be able to manually swing this and watch the protractors or the rotary encoder who want to be fancy about it, and get it to the next setup or the next position, which I kind of, if you can see here, have labeled of, you know, 9 degrees on the A axis, 125 degrees on the C axis, or whichever combo. Each of my setups, I'll follow a sheet, load my programs, and execute these with any 3-axis mill. I can get this to work on any Haas 3-axis, or, you know, any 3-axis mill in the world, really. I can do this on an email, anything. So that's what I'm planning on still doing. I'm really looking forward to doing it this way, actually. It's very, very rewarding, and it's neat to see older machines capable of doing contemporary work. It does have its challenges, and I'm up for them. I designed this whole system to work this way. So there's that. Let me, I'll do another pass through of the cross section just to show. As you can see, I've been having some technical difficulties. Well, I guess that'll close it at once. You'll kind of see how close everything is together. I've taken great consideration to package these to where they're friendly to the mechanic. That you can put these on in your driveway or in your garage. The head will show up, for the most part, assembled with valves. The rockers and rocker train will be separate, but it'll have a very like ABC construction, and you won't have to do much tricky stuff to assemble these. Any aftermarket cylinder head that has a shaft rocker system where you have to put the plate on separate after torquing the head, you'll kind of have to play those games with this. But if you go down the firing order, the rockers should all assemble nicely. I think you'll find setting the valves is actually pretty easy. The difficult spot of setting the intakes apart, I will be handling that on my end. So you'll get a ready to run cylinder head from me. For hop ups, for guys that want to relieve the chamber for like a 4-inch bore or an even larger bore, potentially a larger valve setup, I will be probably doing one larger valve setup, but I'm going to try to work with some of the other shops that I know to have them do upgrades of, if you want the really high RPM ones, or if you have a particular liking to a brand of valves or a brand of springs or anything that you know and then what you can rely on for your racing application. I want to not only be the single source for this. I would like to be able to not only sell, 90% say machined cylinder heads and ship them to a shop and have them put their finish on it. I think that provides the best value to the customer. Let's see here. Let's get a section analysis going. Gosh, this one's really terrible because I can't adjust it there. So let's do another one. So if you have questions on what I've designed this on, this is all Fusion 360. And besides some limitations of stuff, I've really enjoyed using the software. This project and one other engine project, which I'll announce in the future, I've used to push myself to learn a new system. And since then, I've learned 2 CAD/CAM systems beyond that. This is just a great system to learn. It's easy to use. There's plenty of help online. If you find inspiration from any of this, go download Fusion 360. I believe you could still get it for free. Search how to get Fusion 360 for free on YouTube, and you can actually do that legally. Don't pirate software. It's not the thing to do. You can get yourself in a ton of crap with that. I pay for the basic deal. I don't have the machining extension, which I quabble with myself every day. Overpaid $1,500 for some 5-axis tool paths and some lollipop cutters, which, I could tell you I could use right here on the exhaust port. It's really hard to reach. It's not impossible by standard machining and straight ball end mills, but having a lollipop cutter to reach in here and aid the blend would make my life quite a bit easier. So kind of zoom in here on some of the valve train. I plan on having these are 3 O-rings. I don't want oil getting down into the spark plug. One of the advantages with these with a turbo engine is your spark plug isn't sitting out by your exhaust. The spark plug is centrally located in the chamber. Again, it's partially integral with the exhaust valve seat so that it cannot fall out. There's a slight misalignment that I had to do to clear the rocker arms and whatnot, but when you go to tighten this, a a normal socket will, and 3/8 ratchet will be dead in line. There's no tweaking. You don't have to worry about cross-threading your spark plug threads. So there's a little bit of a dog leg. Just don't drop them down here and change your gap. Drop them down, get the little rubber boot thing, and drop them in or get them started with that. These will poke through, kind of like a Hemi, through the valve cover. I think I'm utilizing Honda K-Series tubes because they're cheap and available, and they work very well. And the seals, especially through the top of the valve cover, work immensely. You have to change them like every 100,000 or 200,000 miles before they start weeping oil. That'll be good enough for these. I don't know if I went over this, but with the exhaust exhaust manifolds, factory or like turbo cast manifolds or any LS header will fit on this. This will bolt to this stainless plate here that bolts on with a tighter pattern around each exhaust port to help seal this up, and then also keep the heat from the turbo system off of the cylinder head, and that should aid cooling of the cylinder head greatly. It should be nicer to your valves. It should be actually quite a bit nicer to the whole system. Stainless is a great insulator and also great for turbo systems. So that's what your exhaust manifold will bolt to, or your header will bolt to. That enabled me to put the water jackets in. Without doing that, I would be putting a very compromised water system in this thing. Let me get another angle here on the water. Let's see, we'll go cancel and section view up this way. So I have the valves modeled here in various lifts. As we come through, you'll see the very thick deck. Where I'm not worried about it, I have water initially on the intake, and I've considered greatly about steam and this thing purging, getting the air out of the system. I feel that that's an important factor, especially when you're producing a lot of heat. So as we come up, you can see the cross drilling through the main wells for the water in between each of the cylinders from here, and all these pickup locations pick up water from the steam holes and or the higher flowing holes, say back here, from the stock head gasket, to then let water pursue its way through this thing pretty freely and unabated through. And there's all kinds of different angled holes. If you keep your eye like on this hole, this is actually drilled in at an angle to make sure that even that steam hole has a relief for coolant flow. And as that moves through, you can see the ports kind of looking very strange. But there's the main water channel that will allow any water coming up anywhere in from the rear of the engine to proliferate and flow through kind of this hexagonal shape around each cylinder, as well as mainly, or not mainly, but almost secondarily come through this hole here into this intake cover plate and travel up and leave a distinct high spot so that your water purge happens nicely. If you do steam the water in it, it's got somewhere to go. If you contain that, you're basically building like a boiler, and no one likes permits for that. So as we come up further, you'll start seeing the ports close off and the guides, oh, I'm going the wrong way. You'll see where the guides run. I'm planning on running a brass guide. I'm planning, I assume guys are going to use methanol on the high boost application stuff. So I want to have these come out the hole with brass guides, and that way they're tough, they're easily replaced, and that's kind of the whole assembly right there. As you kind of come down, this is views that you rarely see with cylinder heads, and you see actually how close some of these things get to from every direction, forward, back, left, right, inside, out. Looked at each one of these features, drawn them up, found my issues with them, deleted some features, drew more features. This has been a 2 steps forward, 1 step back development process to fit all of this stuff in. It's obviously very tight packaging, and as you get into the rocker arms, that's kind of a weird way to look at it. We'll look at it from a different direction here. I think picking that, you can see that the shafts are 7/8 diameter shafts. That's the same diameter that top fuel Hemis that make 10,000 horsepower use and hold 1,200 pounds of spring pressure. Each of the rockers have roller bearings that will be installed on each end, and they're freestanding structures so that if there is flex and compliance, most of the force still goes to the valves, and you get the truest amount of detail and data from the camshaft transferred through the rocker system to the valve. Again, there's your clearance for in the rocker shaft for the intake spring. I have quite a bit of room in here. You can see I'll freeze this at this point, and we'll do an inspect of this distance. So we have 2 inches of valve spring height. So I can also drop this floor quite a ways because the port is nowhere near it. I went with an extra tall valve on this, and yeah, it adds some weight, but I wanted to allow a lot of room for expansion, for exploratory porting, customization, and to retrofit the exhaust and intake springs to have plenty of room to grow if it so needs it. So these could also sink down about a quarter of an inch. I think I have quite a bit more height on the exhaust initially as well. So these are modeled to clear things. Let's see here. That's 2.2 inches to the top of the spring. So there's plenty of room for expansion. There's no reason to lift the valves any further. I recommend doing the tricks of, have your springs coil bind, 50 thou pass lift. There's all kinds of stuff that we can get into later that can aid against the valve float. But all of these systems being super thick, I've laid nothing. I've left nothing to risk. Am I not allowed to click that when I'm already in a section view? See, this is development of big files. Well, I'll probably wrap it up right here. I hope this gives you some insight into the cylinder head, into the design, everything that I've done, from keeping the push rods no more than 10 degrees off tappet center line to really good rocker geometry. I don't know if I included that. We can go into that further. Let me know if that interests you. I have a little bit different of a theory on that than the standard keeping it perfectly centered through the arc. Mine's more of a force-based theory. Where your spring pressures are up, that's where you need your roller centered. And you can get the more centered there if you are just a tick off center at lower spring pressures, where the energy and the misalignment of that, which is very slight, but the pressures are a lot less where that misalignment is not ideal. I'm still within like a 1/16 of an inch of center of the valve with the new rocker system, but at a 1/3 lift, I'm dead center, and it comes back. It only deviates like 40 thousandths from the center of the valve, and it's back on center at like 800 lift. And for the love of God, don't lift the valves that high on this. It just is not necessary. I will be getting you a flow bench as soon as I get one of these off the machine, seats and guides installed. I'll get them on the flow bench, and I'll try to make up a 5.3 bore cylinder, and we'll get the small bore flow at what's final. And then I like a 4-inch cylinder for your 6.2 or 6.0 liter engines. The bigger cylinder typically aids in more flow because of cylinder shrouding. I guess the last thing I'll address is, oh Jesus, it's getting uglier, is the chamber shape on this. I try to make my 4-valve chambers like they're 4 independent mini combustion chambers. The less distance this flame front has to travel from the plug, the faster your burn is. I have quench on 12, 3, 6, and 9 o'clock for maximum activity. these CC out right at about 62 cc's, which is very close to like the 706 head. Obviously, going bigger is not a problem, but I wanted to start tight, I wanted to start efficient, and start where the baseline customers get the most advantage out of it. Obviously, as you go up into super big cylinder heads, the advantage of these is going to fall out a little bit to something like the big Dragon Drive motors that are out there, or like a 481X Alan Johnson style. There's still 4-valve advantages there, but you begin to lose that window, or like the Hemis, like they do flow more peak air. And the combustion chamber, when you start softening the combustion chamber for anti-detonation reasons and other logical things of hydrolock, or not looking at pushing so much fuel past the rings because you're putting that much fuel in there, I'm willing to make concessions, and I don't think this is the best combustion chamber for those applications. But for pump gas up to pretty high boost, this will do you very well. And the faster you can convert your fuel and air into a burnt mixture of exhaust, your delta of pressure goes up exponentially higher. And so the fast burn, it's not the heat or the expansion of the flame or like the brisance of the fuel. It's literally you put this much pressure in and you squeezed it, and then you turned it into about 2.5 times the pressure, and that's what pushes the piston down under naturally aspirated circumstances. Boost, that keeps going up, and it is the PSI on top of the piston and how long that is maintained. That is what dictates your horsepower or your torque, and then horsepower is just an extrapolation to convert it to metric, and it's a work over time system. I always focus on the torque band. If you take care of the torque band and you have an engine that eagerly accelerates and doesn't puddle fuel and keeps your airflow and reversion properties as in the most ideal state, you have an engine that eagerly wants to accelerate. And if your torque curve is thick, you're going to have a very, very good racing engine, or just a fun engine for your sand car, boat, whatever. But you'll be able to probably slay some giants with this thing, and I'm looking forward to it. So, well, if you got any questions, comment down below, subscribe. I said it right this time. And also follow me at FY_LSX on Instagram. I put some more detailed notes and maybe a tick more sarcasm there. Thanks for watching. See you next time.